Now 5 times 6 minus 1. So that gets you to 29. So not quite 24, but you're getting close. Also remember, you have to use all 4 numbers to get there. Sarah's good at this. So Sarah is saying 5 minus 1 is 4. Then 4 times 6 is 24. And then times by 1, which means you've used up the 2 ones. Yes, Sarah, A is yours. You will forever be remembered because you have got that one. Let's see if you can get B. Who can get B? How do we get to 24 with B? Oh. Who can get close? I mean, one way of getting there could be 8 times 3 is 24. But then how do I use up the other 3 and 2? What do you think? Simbali says 8 times 3 is 24, and then you say 3 minus 2 is 1, and then 24 times 1 is 24. 3 times 8 plus 2 minus 2. Cameron, you have to use all the numbers that are here. So I think Mbali's got it. 8 times 3 is 24. 3 minus 2 is 1. 1 times 24 is 24. And we're good to go. Okay, cool. Well done, guys. And again, every time we start the lesson, we'll always do a little one. And if you just keep practicing, you'll see that you get quite good at this. I drew that in the wrong place. So let me just scroll down here. So just some admin and announcements. In the second lesson of the week, we do a fun quiz. And so later in the lesson, Coco, who is my able TA who is joining me in the background. Coco, if you want to say hello to the people of grade 11.
I am right there. Hello, everyone.
She will be putting the link to the fun quiz. And the quiz is just a way of getting a sense of how much are you retaining from the class. And it's just basically when the link is given, you go off and do the quiz. You don't have to come back to the lesson. It's kind of the end of the lesson at that point. Okay. All right, so in the previous lesson, we were talking about this thing called trigonometry. And I kind of said that trigonometry is really just about triangles. So, and we spoke a little bit about how right triangles are important and also similar triangles are important. And I touched on this thing that most people would learn in grade 10 called SOH CAH TOA. And what SOH CAH TOA deals with is it deals with the ratios of sides in a right angle triangle. But I find that a lot of students tend to memorize this in grade 10 without too much understanding of what it actually means. And so I just want to start today kind of where I finished off the last lesson by kind of showing you how, if I say something like, what does it mean if I say the sine of 45? Like, where does that come from? And why can I use that in so many different types of sizes of angles and triangles? Okay, so in the previous lesson, I said to you, imagine a square of 1 by 1 by 1. And if you imagine drawing a diagonal across that, you have a right-angled triangle where the angles are 45 and 45. And you could imagine doing the same thing for a squared, which is 2 by 2 by 2. This would have the same, these triangles would be similar. They're the same shape, but they're not the same size because the second triangle is a 2 times enlargement. So just give me a thumbs up if you understand what I mean by that. Like I've got a square and then I've cut it in half to get a triangle. The 2 triangles that I'm focusing on, here's the one triangle. This triangle is, we say it is similar to this one over here because it has the same shape, but not the same size. Okay, that's an important difference. Now, if we take trigonometry and what trigonometry really is all about, trigonometry is almost like about internal scale factors. So if I say to you, what is the sine of 45? If I want to visualize that in terms of this triangle, then I'm going to nominate one of these angles as what I call my reference angle. So it'll be this 45. Then this is the hypotenuse. That would be the opposite. And this would be the adjacent. And using the same logic, this would be the opposite, hypotenuse, and adjacent. So in your calculator, what it's got stored for the sine of 45 is the length of the opposite over the length of the hypotenuse for a triangle which has 45 degrees as its reference angle. Now, I don't know at the moment what the hypotenuse is. Who can tell me what the hypotenuse is, and how do I know what the hypotenuse is? I covered this in the last lesson. If this is 1 and this is 1, what is this hypotenuse length going to be? And how do I know what it is? Coco, can you give us a hint as to what fact do you think I'm going to use to figure out the H?
I think his name was Pi something.
Yeah. So using Pythagoras, we can say that H squared is 1 squared plus 1 squared. And basically then we get H squared is 1. Oh, sorry, H squared is 2. 2. Sorry. And so that if we square root both sides, we see that H is square root 2. So in your calculator, you will see that the sine of 45 is just 1 over square root 2. Now, what's interesting about this is that this process still works for the other triangle. So let's just pop across to this side over here. Look at this one. We know the hypotenuse here, it's not going to be square root 2 anymore. It's just going to be 2 times square root 2 because it's double the size of the other one. And if I have to imagine what the sine of 45 is from this triangle, it's going to be 2 over 2 root 2. Now, the funny thing is, guys, is that even though these look different, if you put them into your calculator, they give you the same answer. So I want you to do that now. In your calculator, type in like 1 over root 2 and get a decimal. What do you get for that? So let's, let me turn my light on in the background. So we get 1 divided by square root 2, and then I get like a funny root thing, and then I hit the SD button, and you should get 0.707, something like that. Now I want you to go to sine 45 over here, and I want you to type 2 divided by 2 root 2 and see what you get for that. Are they the same or are they different?
The same.
They're the same, right? Okay.
The same.
So guys, this is the key idea in trigonometry. If you have a triangle that is similar to another one, the ratio of the sides doesn't change. So even though this big triangle over here is bigger, because it's similar to the smaller one, when you divide the sides, you get the same number. And so that's why we can use sine 45 all over the place, because as long as we have a pair of similar triangles, the ratio doesn't change. And what I call that ratio, I kind of call it an internal scale factor. No matter how big your triangle is, as long as it's got the same reference angle and it's a similar triangle, you can use those numbers to help you find stuff. Now, I think some of you might still be a bit unclear about what I'm doing with this. So I want to go to some concrete examples now and show you how we can use this idea in actual examples. But let's just start with a couple of questions, actually. Let's first do this. If I gave you this multiple choice question, and I gave you those sides, I want you to choose, what is the value of the sine of theta in this particular triangle? Is it A, B, C, or D? Because what I said before, it kind of makes sense if you think about it, but you'll get it if I use it again and again. Okay, so if I want to know what the sine of theta is, this is just a ratio of two sides in a right angle triangle. I have a right angle triangle. This is my reference angle, and so this is O, that's H, that's A. And so we know from the SOH CAH TOA thing, the sine of a particular angle is going to be over H, which is going to be 3 over 5, which is 0.6, which is D. And so the internal scale factor for this is just going to be 3 over 5 or 0.6. Okay, now not everyone got that right, but a lot of you did, and there'll be plenty more chance to practice. So here's practice number 2. What is the tan of theta? And I'll put this little okay, so if this was tan of theta deals with opposite and adjacent. So I know I need this one and I know I need that one. So it looks to me like the tan of theta would be 3 over 4, which in decimal is 0.75. Now, just to show you what I meant about how size doesn't matter with trigonometry, as long as you've got similar triangles. Imagine I blow up this one over here. And this is going to be 8, that's going to be 10, and this is going to be 6. In this bigger triangle, what is the tan of theta going to be in the bigger triangle? So do you understand what I'm saying? I'm saying I'm no longer looking at this one. I'm looking at this one. There's a right angle. This is a 2 times enlargement. What is the tan of theta in this one over here? Well, it's going to be 6 over 8, which is 0.75. Now, notice how the size doesn't matter. And the reason the size doesn't matter is these are similar triangles, because I've just enlarged it. So as long as I could have a triangle as big as the universe, as long as it's similar in shape, the internal scale factor or the trig ratio is going to be 0.75. And that's the real power of trigonometry, why it's so useful. Okay, but I think I've made my point there. Let's move on to another question. Got that one? Okay. Little bit more tricky. What is the value of the cos of 60? And again, the cos of 60 is just a ratio of two sides. But what is it going to be in terms of what you know about trig? Okay. So if this is the reference angle, this would be O, this would be H, and this would be A. Because remember, this angle over here, that's the real important, that's what we call the reference angle. Now, I haven't drawn it in here, but it's kind of implied that's the 90. Now, once you know 90 and one other, we don't actually have to think. We know what that angle is because all angles add up to 180, but it's not important. So at this stage, the cos of 60 should be A over H. And so it should be 1 over 2, which is A. Now, I caught some of you because some of you assumed that the reference angle was this one here. And it's good that I caught you because one of the important things with trig is that the names of the sides depend on what you nominate as your reference angle. So give me a thumbs up if you understand now, after having done that question, why the O and A will change position depending on what angle you choose as your reference angle, because that's an important idea. Okay, good. Yeah, that was the main point of me kind of just going through that one. So we have to be careful about our trig ratios or internal scale factors. We have to make sure we know what the O is, and the O depends on where the angle is chosen. Okay, what is the value of the tan of 60 in this one? And I want you to put your answer in the chat. Okay, it says without a calculator, but I think maybe we'll allow a little bit of cheating in this one because so we'll make that O, that H, and that A. So the tan of 60 is going to be √3, because O, and then well, let me actually do SOH CAH TOA because otherwise. So this is just a clever way of remembering what relationships are defined. And so because we want tan, we want O, which is this √3, and then A is going to be 1. And √3 is going to be, so it's less than 4, so it's going to be 1.7. It's going to be D. Yeah. Okay, I'm going to make a remix here. I want to know what is the answer for the tan of 30 using this triangle. And I want you to think, how can you use the triangle to help you? What is the value of the tan of 30? And I'm actually not going to, I want you to sit with this for about a minute and think, what can I use in the drawing? How would I work out the tan of 30 using what's already on the drawing? And what would I have to change and what would be different? So first of all, we need a 30-degree angle, don't we? But isn't this one equal to 30? But then how does that change things? Well, this would be O. This still is H, and that would be A. So the tan of 30 would be O, which is 1, over A, which is √3. So 1 divided by √3, and if you put that into your calculators, you get 0.577, which is B. Okay. Give me if you feel like you understand what I'm doing, give me a thumbs up. If you don't feel like you understand, give me a thumbs down. Because we're moving along quite nicely now. Okay, Coco, anything from you or any comments from the chat? Anything?
No, I think they've got it.
Got it. Okay.
I'm happy with this, or maybe, but we'll discuss it in the chat.
Okay, now I'm taking it up a notch. What is the value of the sine of theta plus the cos of theta given that drawing? And I'm going to give you some time, and you'll notice that we call this a trig expression. I'll make it, we're basically evaluating this. What is the sine of theta? And all this is two trig ratios added together. But once you've got a ratio, you've got it. I see a couple of answers coming through. That's good. So like all trig questions, we have to start by making sure we get the names of the sides correct, because sine means a particular thing. Theta is the reference angle. And so I would have O, so I'll write this again. So sine is over H, which means it's 7 over 25 plus cos is A over H, which is 24 over 25. And because I know my fractions, I know the denominators are the same, so I get 31 over 25. And I get 1.24, which is C. So we get C. That's it. Yeah, and so you can see how once you understand what the definitions are, it kind of it's not too bad. So this is all about naming and getting comfortable with the trig ratios. All the trig ratios are, I call them internal scale factors. They're the length of one side divided by the length of the other. I think we got one more. Let's see. Okay, let's do one more and then we're done with this because I feel like we've mastered it then. What is the value of cos of phi? I think that's the Greek letter phi. So HOA, we know that cos is A over H.
Oh, hi guys. I think we've lost Peter for just a second. Yes, Sarah, I think he was lagging. He should be back in just a second. Just give him a second. And Kaka says, Ma'am Coco, if I may ask, what's inside that triangle? Well, that's a tough question to ask without having the diagram in front of us. But let me see if I can get Teacher Peter back in here. Then maybe he'll be able to help us with that. Oh, yes, sorry. The letter on the inside was it was phi and not theta. We are not authorized to do that. According to the Poppy Act, we cannot ask for any personal information. So I cannot, unfortunately, allow that. My apologies. All right. Okay, guys. So I'm going to try and pick up where Peter left off. If you just give me 1 second to share my screen and then we can continue. Okay. Oh, he says he's on his way. I think he may have just got disconnected. Okay, just give me 1 second, guys. All right, guys. So I'm hoping I can replicate that question again in just a second. Oh, here he is. Oh, thank goodness. All right. There we are. Hi, so you're muted.
Sorry, guys. I don't know what happened there. So, yeah, let me just get back to my question. I was being a bit sneaky. That's what happened if you're a bit sneaky. I want you to find me, I'm going to call this phi. Can you find me the value of the cos of phi now? What's going to be the value of the cos of phi now with this particular one? Okay. Coco, are you sensing my sneakiness yet or not?
I see it. I do see it.
Yes.
I do.
I'm luring them into a trap. Okay. Okay, let's see the answers. What do we have in our chat here? Okay, guys, confession time. I have been sneaky and I've changed this triangle, this right angle. This triangle is no longer a right angle triangle. So what happened is I basically took this bit here. Look at that bit there. It used to be a right angle, but it's no longer a right angle. And so when you have to calculate trig ratios and you no longer have a right angle triangle, you need to have a very special way of doing that. So if you find the cos of phi for this, it's not going to be valid. And the reason I did that was we got so comfortable thinking every single triangle in the universe is a right angle triangle that it turns out there are other types of triangles. This is an obtuse angle triangle because this is greater than 90. And so when you get a triangle that is greater than 90, you need to then think about, you use a different type of trigonometry, which we will cover later in this course. But for now, I just want to put that as an explicit warning. Always check that you have a right angle when you're finding trig ratios to start with. Okay, give me a thumbs up if you understand what I did. Give me a thumbs down if you're like, huh? What's this funny person doing? I'm just trying to show you the importance of always checking that there is a right angle. Okay. All right.
Can you
Good.
please explain again?
So all I was saying was that when you figure out the cos of an angle, I want you to first check that there's always a right angle in that triangle. So until you learn some other tools later that can help you get around this, but for now, the triangle that I drew down here, it doesn't have a right angle. Because it doesn't have a right angle, it doesn't have a hypotenuse. If it doesn't have a hypotenuse, how can you then apply trig? Because trig depends on right angle triangles at the moment. That's all I was trying to say. Okay. Now, we're going to have a little break, but before we go on, what's the whole point of this? So the next bit of today's lesson is going to be about you know how to work out trig ratios, but the whole point is, how do I find unknown sides in trig ratios? And later on, how do I find unknown angles? Because you've worked out how to find, say, the tan of 45, which is a value, it's an internal scale factor. But how can I use that number to help me find things in triangles which have things missing? Okay, but before we do that, I want everyone to stand up because we've been going for a while. And so I want you to stand up and get away from your tables and desks. And we are going to do a different type of brain break. For those who've been here a while, you know what I'm going to make you do. And I'm always open to new brain breaks. So Coco or anybody who likes finding brain breaks on the internet, I will hand over the camera to you anytime. But for today, I will go with my the one I know in the back of my head. Okay, so you take your right hand. There's no pens today. Right hand, put it on your nose. Then take your left hand, put it on your right ear. Now, you're going to take this hand on your ear, and it's going to go to your nose, and this hand goes to your opposite ear. So see if you can then take this back to the nose, opposite ear, then this back like that. And see if your brain can help you figure that out. And then as your brain starts to give you like, oh, I've got this, see how quickly you can change back and forth. And so I'm told this is called a midline crossing or something. And it's actually quite hard for our brains to do it, but it is a necessary skill for like reading and things like that. You kind of have to master this. But it's a great way to get all your concentration on one thing and far away from maths. And so that's why I love to do it, because too much maths can make your brain get a little tired. So I love to do that with my students. And also if you're in the physical classroom, just like online, you need a break sometimes. So, all right, let's get back to what we were doing. So in summary, we've learned about how to find trig ratios. Trig ratios are internal scale factors. And we're going to use this knowledge to help us solve for unknown things. So I'm going to do the first one with you, and then I'm going to let you do the second one by yourself. So how do we solve these? So we first check, we need to figure out the length of A, which is this unknown side. And we're given 3 pieces of information. First, right angle. Second bit, another side. Third bit of information, an angle. What I'm now going to do is I'm going to say, what have I actually got and what are the names of those things? So in terms of the naming we've done for trig so far, this is the H, this is the O, and this would be the A rather conveniently. So I'm going to write down what we want to know, which is A, and divide it by 16. And ask yourself, in fact, I'd like to know in the chat, what trig ratio is A over 16? Who can tell me in the chat? Okay. It is, A over H would be cos, and what angle is going to be featured here? Cos of what? What's the angle involved? So it's going to be 31, because 31 was the reference angle, right? Or the, that's the angle that gave this life. So essentially we got A, which is the unknown, and we always try and put the thing we're trying to find on top by itself. Divided by 16 is cos of 31. Then we use our powers of kind of equations. We say, look, I'd love to get rid of the 16. I can't just get rid of it, but what I can do is I can multiply both sides by 16. So let's do that. In which case 16 over 16 is 1. And then A is 16 times the cos of 31. Look at how we are using the internal scale factor to help us. Okay, so we know cos of 31 is a value. It's an internal scale factor that is true for all similar triangles. We use that and we multiply it by 16. And what do we get? 16 times the cos of 31. And we have 13.7, which is A. So that is how we would solve for an unknown side using a scale factor from a similar triangle that's stored in your calculator. So over to you guys. Time to shine. What is the length of side A in this particular triangle? Oh, let's tilt this down. So I haven't actually worked the answers out for these, so I'm going to have to do that with you live. Here we go. H. So it's a bit confusing because it's O, but it's called A. And then this would be A. I like to use capital letters for my sides so I don't get confused. Okay, so answers are coming in. I want to know, so it's O over, I suppose I can always put this here, O over A, and over A is going to be the tan of 15. Just make sure I've got that right because my brain is like, definitely O, definitely A. So it's A over 21. That ratio that's involved is definitely tan, and the angle is 15. And then if I multiply both sides by 21, I get that. 21 times the tan of 15. Ooh, why is this not being nice to me? I get 5.62, which is B. Yeah. Awesome. Okay. Find me the length of side A and put the answer in for that. I suppose I should work these out on paper before I can. So what do we have? So this is going to be big O. That's going to be big H. That's going to be big A. What trig ratio is going to be involved? It's going to be O and H. So it's the sine of 64 is equal to A over 10.8. And then if I times both sides by 10.8, I end up with 10.8 times sine of 64 is A. Sine of 64. I get 9.7, which is C. No, you guys are all on fire here. So it's C. Okay, Coco, anything from you? I think it's time to mix things up. So now, instead of knowing unknown sides, we are going to find unknown angles. And so what we have to do with this is we can't use the normal trig operation. We need to tell the calculator we're going backwards. And so what we do is we use the inverse trig operation. So just to give you an example of how this would work from the previous question, actually, you are going to tell the calculator the two sides that you've got, and it's going to tell you the angle that you need. And the way, in fact, let me do the first one together with you, then we'll go from there. But the inverse operations, normally, it's not to the power of 1, but they have they look like that. And that means I'm not trying to find a number, I'm trying to find an angle. But I think it's better explained through an example. So you are given two sides of a right-angled triangle, and you want to know what is the angle that gave you this triangle. So what you do is, again, you name your sides. So this is O, that's H, that's A. Now, the only trig ratio that's involved with O and H is sine. And so you're only interested in sine. So you write down sine. And when we say sine, we have to have a reference angle attached. So it's the sine of X is equal to what? Well, the sine of X is equal to O, so 7 over 10. So now what we have is we've written down a trig equation. We know that the sine of X is 7 over 10, but what we really want to know is what is this X over here? And in order to get that, we need to apply the inverse operation to sine, the thing that gets rid of sine. And so that operation is essentially sine to the -1. And we applied on this side, but we also applied on this side. Sorry, guys, for all this. And what it ends up being is, in your calculator, what is inverse sine or arc sine of 7/10? And so let's type that into our calculators now. Shift. So we have to hit shift sine, and then you go fraction 7/10. And you should get 44.42, which would be B. And so I want you to look on your calculator. If you've got a Casio like me, you should see a shift, like you go shift sign or shift cos to tell the calculator you're now going the opposite way around, or the inverse process. Give me a thumbs up if you feel okay with that. Give me a thumbs down if you don't feel good. I think I've got a screenshot somewhere I can grab. Where did I store those? I think it's hiding up here somewhere. Oh, here it is. Okay, let me grab that. Control C. We were down here. Sorry if I'm making you dizzy. So basically, if you have your calculator, in this case, it's doing normal cos. I want to see you go shift cos and then, or shift sine 7/10. Okay. So shift, and you'll see there's a yellow thing to give you -1, and then you type in the ratio of the sides. So let's see if you can do this. I'm going to ask you to do question 2 and question 3 at the same time now. So I want you to first, you can put both answers in the chat, and I'm going to take a water break while you
So can you please zoom? We can't
Zoom?
see.
Okay.
Yes.
So I'd rather one at a time. There you
Yes,
go.
please.
Okay, cool. I see some answers coming in. Let's have a look. Give a little bit more time. So I know that's H, that's O, that's A. Now I want to find the angle X. So what I need to use what I'm given, and what I'm given is O and A. So I know the ratio is going to be the tan of X. And if I write in the information I've got, tan of X is over A, so 10/8. And that is just a statement. Now I need to actually find what X is. So I'm going to get, if I take inverse tan on both sides, I'm going to end up with that in my calculator. And I should get 10, that's 10 divided by 8, 51.3, which is C. Okay. So again, guys, also the other thing is, if I'm going a little bit quick for you, remember this is recorded, so you can always come back and look at this if you need to. But I've just taken inverse tan on both sides to get the X by itself. And then the X is an angle. So basically this is 51.3 degrees. Okay, let's do number 3.
It's A.
Oh, okay. You guys are getting faster and faster each question. H, O, A. I want to use A and H, so it must be cos. of x is the same as 5 over 8. So guys, can I encourage you, always write the step out first. As a teacher, if you make a silly mistake in the next step and you get the wrong answer and you haven't showed me the step, you just run unnecessary risks. So please do write that step. And then the next one is, if I take, notice how suddenly this is going to disappear. And the reason is I'm taking inverse cos from both sides. And so I'm going to end up then with x equals that, which is cos 5 over 8, 51.31, which is, did I get that right? 5 over 8, 5 over 8, and you guys get A, which is, yeah, good. Okay, how much time we got left? Let's see if we can squeeze in. I think we're almost done for today. Okay, let's leave it at that point. We can always carry on the next lesson. So I'm gonna pause at that point. Ask Coco, could you put the quiz link in the chat? And then for students who would like me to go over something or clarify something that they're unsure of, if you put your hands up now, I will gladly kind of give you a little explanation. But the main point of today was basically understanding trig ratios, like what they are, and making them less kind of memorized type thing. And what I said was they're just internal scale factors, really. They're numbers that we know about, that tell us about the relationship between the sides of a triangle, and they work no matter how big. As long as two triangles are similar, it doesn't matter how big they are. And then we worked out, using trig, how to find sides and how to find angles. And there were two different methods that we kind of used. And we need to get quite comfortable with that. And this is sort of grade 10 trig, but unless you have this completely down, there's no point of going into grade 11, because it all relates back to these basic ideas. Coco, anything from you, or comments or questions?
None at all, but I have posted the link in the chat. So you can either use the link, or if you want to go back to the Watobe website and log in from there, you should be able to take the quiz. Maybe you might want to try it now in case you run into
I think it's a good idea. Yeah, do it now while it's fresh in your brain. By Kamvaletu, I think it's always good to get it done now. And then you are going to forget some stuff before next week, but that's part of the learning process, and you just scale it. Ronewa, I think you have a question. Do you want to let us know?
Oh, yes, sir. It's like I was practicing trigonometry, right? So there was a question that says, if cos theta is equals to 8 over 17, and
Cos
sine
theta 8 over 17, yeah.
and sine theta is less than 0.
Okay. So
And
this
then
is, yeah.
And then they said we must find the value of 10 theta, and then we are supposed to draw a diagram in the correct quadrant.
Okay. What are you trying to find? Give it to me again. What's the thing you're trying to find?
So we are trying to find 10 theta.
10 theta. 10?
Yes.
10 theta.
10 sine theta. Okay. Okay.
No.
No.
Tangent theta.
Say that again, Coco.
Tan theta.
Tan theta. Okay.
Yes.
Okay. The reason we haven't covered this yet is because it deals with the idea of sine being negative. So at the moment, because we are just seeing sine as a ratio of sides, we haven't dealt with the scenario where sine can be negative. Now, there's a lesson coming up on this where I talk about reduction formula and trig graphs. In fact, the next lesson. But just to show you how you would do it, well, I can't do the whole thing now because it's kind of beyond the scope of this lesson. But the sine of theta, we use something called the cost diagram. And so you basically have to draw a diagram where you draw a triangle because the triangle is what's going to allow you to work out what these things are. And so you have a choice about where you put your triangle in what quadrant. Now, sine can only be negative in this quadrant or this quadrant, and cos is only positive in this quadrant. So basically what I'll talk to you about in the next lesson is that you have to draw your triangle in this quadrant. And so once you draw your triangle, you then go, well, okay, this is going to be H, this is going to be A, this is going to be O, and you start to put the sides in. So this would be 17, this would be 8, and you work this out using Pythagoras. But I'm going to give you that tip, but this is something which I want to rather build up to. It's a little bit beyond the scope of this lesson. This lesson was just about knowing a single triangle in space without any Cartesian planes.
Okay, sir.
Yeah. But
Okay, thank you, sir.
Okay. Yeah. Anybody else?
So I want to know, have we
Yeah.
covered already the general trigonometry?
No.
Or are we still going to work on it?
We're going to work on that. So if you look at my planning, trig equations or general trig equations is sort of more or less in 5 and 6. So today, what we did in our lesson is we did what we would call specific trig equations. So if I say to you the sine of x is equal to half, that's a trig equation, right? But
Yes, sir.
it turns out that trig functions, or when you think of a trig ratio as a function, as something that repeats itself, you then don't just get one answer, you get multiple answers to a trig equation. But in order for that to make sense, I need to extend the definition of trigonometry from just being a plain old triangle, and I need to make sure that an angle can be more than 90, which I haven't really talked about yet, but that's going to come in a later lesson. Okay.
Okay, sir.
Cool.
Thank you, sir.
Yes.
Bali was just asking if you could go back to the question where you were looking at I think the cosine of 60. I think it may have been just
cosine of 60.
I'm not sure. I think it's this question here because it says classic 60 degrees. I'm not sure what classic 60 degrees in Bali. Maybe if you'd like to unmute and help us.
60. I don't.
Yeah, I don't quite see the question she's asking for.
Okay. No, it's fine. I think, look, today's lesson was really about consolidating our basics, that we build a good base for going into the sort of more grade 11 trigonometry. But my experience with students is that they don't understand where trigonometry comes from. The general solutions and the trig graphs and all that stuff that comes later, it doesn't really mean anything. It's just this abstract idea. So that's why I try to do this the one with square root 3. With root 3. Let's have a look.
It's all the way at the top, a bit further up. So.
Okay. Root. Oh, yes, of course, because it's right at the very beginning. Okay, so we have this one. Not root 3 there. Root 3. Here we go. Yeah. What do you want to ask about that one?
So I don't understand the whole situation. What's happening there?
Okay, let's just first of all make sure we know that this is a 90-degree angle and this 60 up here is here. The only thing I want you to think about initially is, can we give the sides names properly? And I think this being the hypotenuse is pretty clear. Okay. Now, what is the side opposite the 60 going to be? Can you tell me what's the side opposite the 60? Is it O or is it
opposite.
A? It's opposite.
It's O. Yes.
O. And because that's O, that has to be A. Okay, so that's step one.
Yes.
If you want to find the cos of 60, the cos of 60, then it's helpful to think about this like acronym just tells us the ratios that go with different names. So for the name cos, I'm going to go up here and I see I have the sides A over H. Now that's A over H in a particular triangle. So the particular triangle is a triangle that has a reference angle of 60. So I've got that. So what is A? A is the length. So let's do that. Let's just write down. I want to know what A over H is from this triangle. A is 1 in this triangle. I can see there's A, it's 1. What is H? H is going to be over here, which is 2. And so that's why I get 1 over 2, which is that one.
0.5.
Yeah.
Oh, thank you, sir.
Pleasure. Cool. Alrighty. I think we're going to wrap things up for now. Sarah, may I please ask if, let's say we want to answer a question, are we allowed to unmute and say our answer, then mute back? Okay. So Sarah, if you want to make an audible comment, the convention is that you raise your hand using like the virtual raise your hand, and then Coco would just come to you and say, please ask your question. If you want to reply straight away, you reply in the chat straight away. Because if we had too many people unmuting out of time, we have about 80 or 90 or 100 people in the class, it gets a little bit overwhelming at times. Yeah. Okay, Coco, thank you very much. It's amazing how each time you do these lessons, you get a bit more into it. So I feel much more into it again than Monday. And yeah, thank you for helping out. It was great having you along the way.
Thank you. So I think these lessons are very enlightening. But yeah, guys, we will see you all next Monday. Remember to do the quiz so we can see where you are.
Yes.
Nkulunga, I see your question. You're asking, when are we going to do circle geometry? We had already covered circle geometry in term.
But the good news is, if you go to the Watobe website, I poured my heart and soul into that circle geometry thing. So I really recommend look at the recordings because we really went from the very beginning and try to build it up week by week. And so there's 10 hours of circle geometry. Letabo reduction formula, we're going to start doing that in the next 2 lessons. So reduction formula will start happening in the next 2 lessons. You can see my planning over here. Okay, time to head on out. I will see you guys on Monday. Ciao, ciao.
Right. Bye, everyone.
Cheers.